Well, welcome to 23 Degrees Sideways. So today we're going to talk a little bit about electric conversions. So there's a kind of a lot going on. We're down the coast a little bit. It's cold. Like the whole southeast got cold. So things are a little bit weird, like snow in the Carolinas, everything, We've been talking about that for a while. Let's go ahead and talk about electric motors. You can probably hear the diesel heater in the background. I will take a moment and say it's great. If anyone wants a video on it, tell me. It's one of the H-calorie toolbox heaters, the fully enclosed toolbox, and it's actually really cool because I have it mounted in a deck plate through hole behind me. I haven't done all the permanent stuff. You can see the aluminum foil there that I'm using as part of the encapsulation. It helps dissipate the heat. I'm going to work on a better ducting system, but then those deck plates screw in and make a solid watertight seal. I've got one on each side, so I could run the diesel heater in either side of the cockpit. It's on this side right now because we just docked on the other side, and it's easier to get on and off the boat. I prefer it on the other side, but I didn't. And we might turn the boat around if we stay here for very long. Who knows? So where are we at with that? It's great. It runs great. The pump is loud, and it would be more efficient if it was installed inside the boat. But this way we have fresh air supply coming into the boat through the heater, and air quality is more important to me than the efficiency of the diesel. It doesn't burn too much. It heats up the boat really fast. It actually works really well. It does draw anywhere from 10 to 40 watts of power, depending on how high you've got the fan cranked up. And I have not been able to make Bluetooth work on it, but it works. It's good. The fact that it's portable means I can just put it away next month and not get it out until I need it. I kind of like that. It is also spoiling me dramatically because now, even though we've had this cold snap, and I mean, you're getting the heater temperatures all the way down into Florida. So just being in South Carolina is not going to fix this, right? It's spoiling me because now having the boat at 65 degrees, it's less fun to leave the hatches open when it's 38 degrees outside and just work through everything. You kind of have to make yourself do that. It's nice to have a sauna. It feels like a sauna, right? 70 degrees feels like a sauna right now. That's quite a trip. So it's nice. I do want to talk about the electric propulsion because I'm looking at that. If you follow the channel, I've got a 9.8 4-stroke outboard in the back of this boat, and it does really well as long as we're going slow. I still have not updated the prop. Like, I haven't pulled it out and really figured out the high thrust prop answer. So we don't have that yet. As long as we're running at a moderate speed, it sounds and feels comfortable. It's a pretty low speed. We're doing 3.75, 3.68, something like that, knots in flat calm water at slack tide, burning a third of a gallon an hour. Now, the problem with this is that it is literally slower than jogging. So it's slow, okay? That's really what it boils down to. It's not 5 knots. It's not 7 knots. And a lot of people who go slow are going 5 to 7 knots. We're doing just under 4. A brisk walking pace is about what we're doing. And it takes a while to go anywhere. But a third of a gallon an hour means that we're getting 13, 14 miles to the gallon in a boat, which is just unbelievable. I mean, we're getting 10 times the gas mileage the smallest purpose-built trawler that we could find would do. Okay, we're doing fantastic, right? That's all there is to it. That's all you can say about that. It is efficient enough that we've got the option to consider switching to electric and make it work. But there's some factors that go into this. Okay, so factor number one, we're still going to have a generator. We're not going to be able to store enough battery. We're not going to have enough battery storage and enough solar, wind, everything, generation capability to just go and not have a generator, not have an alternate power supply. So I'm willing to deal with that because I'd rather run a generator periodically and replace a generator periodically than deal with the outboard. And making the outboard easier to deal with is certainly an option. Like, I haven't really committed myself to this electric project. Making the outboard more efficient to get at. Basically, it needs to come inboard a certain amount and be accessible on the side and the back. The easiest way to do that is probably to take it from the center transom mount. It's mounted right in the center of the boat, right across the outboard well that the boat was designed with, and move it to the side. Moving it to the side would do several things for me, actually. It would make it so that I could steer, have a reverse gear. I can't use reverse because reverse just blows right into the rudder and just shifts the rudder. And even if you're trying to hold the rudder straight, it doesn't do the job. So basically I have no reverse. So that might be better. I can get the engine, the outboard motor, closer to the boat and lower down without hitting the rudder. That's actually a problem with these. When this boat was designed, it was kind of expected that you were going to have a short shaft and the prop just barely in the water, and you would tilt up your little 6 horsepower 2-stroke into the outboard well. And so the outboard well is not big enough for what we've got. So that's why it's mounted on the back on the cantilever to begin with. Moving it over to the side, I can probably bring it in a little bit. I could also make a swim step pass through where the outboard well is now, and that would make it much easier to actually work on the engine because I'd be able to get next to the engine instead of having to reach 2 feet past the transom to do anything. So maybe, right? These are all options that are in here. Now, if I want to go electric, what we're talking about is doing 2 pods. You know, if you go look at trolling motors, look up electric trolling motor. What it is control circuitry on top and a pole and then a pod, an electric motor pod with a prop on it, propeller on it, on the bottom. They're called pods. Trolling motor is a built thing with a pod. You can just buy pods and do your own wiring and stuff. You don't have to do it simple. I could get a couple of trolling motors with 2 kilowatt pods, 2.5 kilowatt pods, 1.2 kilowatt pods. And I don't know where that goes. That's kind of the problem, is I don't know how much power I really need. I want to do 2, very specifically want to do 2 because a single electric, call it an electric outboard because that's what most people call it when it gets to that stage, that is big enough to absolutely positively run this boat. So we're talking a 4 to 5 kilowatt electric outboard is going to cost 3 times as much as what I'm trying to think of doing. So that's just, it's a factor, right? And it also becomes harder to replace, more theft prone. There's a whole bunch of factors that go into that. And it's going to absolutely require a 48 volt system. Excuse me. If I do a 24 volt system, 2 24 volt banks, all right, then we're talking about being able to, start with, because I have the outboard, I can rig the mount for a couple of Newport, they call them 86 pound or 90 pound or something thrust motors. They're 1.25 kilowatt, 48 amp at 24 volts. This is the only problem with 24 volts, is that the amperage draw as you make the pods bigger is going to get really hefty. 100 amps of power is a lot to push through wire. So, you know, when you get to a beefier motor pod, you're going to be looking at 2-gauge wire. You know, you got to deal with heat dissipation and stuff. And that's where running 48 volts works better, or running 36 volts works better. 24 volt is a really happy spot for purchase of batteries and messing around with power level of different motors. Okay, when you go to 48 volt, it's actually harder to find a lighter motor, like, because if 1.25 kilowatts on each side actually works, then why would I need more? You know, I don't expect it to. I expect it to work well enough to do that walking pace, 3.5 knots in flat water. I don't expect it to do 5 knots in water with any motion or wind, and that's what I really want. I want that 5 knots. Our hull speed on this boat, let me take a look here, pull up my notes. The hull speed on this boat is like 6.5, something like that. 6.25. So using the water line, square root of the water line as your basis. If you go, the square root of our water line is 4.6. So going at 4.6 knots is the top end of efficient. It burns about twice as much fuel for us to go 4.5 knots as it does for us to go 3.25 knots or 3 3/4 knots. So you go from 1/3 gallon an hour to 2/3 gallon an hour. Okay, running at 0.7, 0.8 of the square root of your water line, and people just call it SD. Okay, that's really efficient. That's the most efficient. Running at 1.0, 1.1, 1.2 is all great, but it's not as efficient. Once you get above 1.2 SD, which for us is 5.5 knots, you start getting into really dramatic. You have to push really hard to get just a little bit more. So 6 knots, I measured at a guesstimate based on fuel usage the few times that we've run really heavy, that doing the 5 knots that with our prop, which isn't efficient for what we're doing, running 5 knots is using 1 gallon an hour. So that's, we're talking 1.5 gallons, 2 gallons an hour to get up to 5.5 knots. So less efficient. Okay, just gonna leave that there. Having the right prop obviously helps with that, but it's a factor. Okay, so our max speed is around 6 knots, just over. So running at 3 3/4, 4 knots is pretty decent. I just don't know how much power I need to do that in regular weather. Let's say we're dealing with a 10-knot breeze coming off of the port forward quarter, off the starboard bow, whatever, coming at us. And we're not running a sail because we're in a bad spot for that, and maybe we're fighting a current or something. I need to be able to push that forward, that headway, 4 knots against the wind. That's what I need to do. I need to be able to do that comfortably with the electric, and I don't have to do it right away because I do have the outboard, and if I don't move the outboard and I put the pods on either side, then I'm kind of committing to the change. 24 volt means that I can do this for a very reasonable amount of money. All right. For example, so a 48 volt, a good 48 volt, 150 amp hour battery is $1,000. A good 24 volt 100 amp hour battery is $400. 200 amp hours, you're looking at $600 to $900 depending on brand, and that gives you a lot. So if you're running the smaller, the Newports, if you can run that, if that 1250 kilowatt motor is good, then at a reasonable, because you can't run it flat out all the time. So you're running it at 35, 40 amps. You've got a couple hours that you can run on a 100 amp hour battery with no generator, with no solar, with no wind. And that's not much. Okay, that gets you, that's not much at all. All right, for cruising purposes, it's not a 6-hour day, You really want to do your 6-hour day. You want to be able to do your 8 and 10-hour days. But for cruising purposes, it's not comfortable to do 8-hour days all the time. It's like driving. Okay, when we're driving across the country, I have a bad tendency of just driving and driving and driving and driving and driving. And so I'll end up doing these 8 and 10-hour days, and then I get frustrated, and I don't actually want to do 8 and 10-hour days, right? So the best option is to have a spot, a schedule, a thing that you're going to do, a destination planned out where you're 4 or 5 hours in, and then enjoy your day. And there were a couple times when we were traveling with the older child who helped us out with scheduling. Like I could toss her the, hey, look up hotels, look up campgrounds, look up whatever, parking lots, look up truck stops. Depends on which part of the country you're in, where you can stay when you're doing the van camping thing, and find a spot, and then we could go and we could get there and we'd have daylight and everything would go well. And if we didn't do that and it was just me pushing, I would push until sunset, and then we'd start looking for anything within 80 miles of us, and then it turns into a very long day. You don't want to do that. You don't want to do that cruising in your boat. Doesn't matter with sailboat cruising, trawler cruising, power. If you've got the Sea Ray doing 40 miles an hour, you still don't want to do 8-hour days. You want to enjoy the trip. You're cruising, right? So with electrics, you definitely have to have the generator. You want to be able to run your 4, 5, 6-hour days. You don't want to have to do it all the time. There's also sails to deal with, but when you're on the ICW, we've found there's not a lot of sailing. There's just there's stuff. Okay, so we're not going to talk about the sailing part of that a whole lot. And often, if you've got the right wind and you're going the right direction and you're not on one of the narrow parts of the ICW, you can throw up a jib and get an extra 1/2 or 3/4 of a knot for free, and that's all great. So we're doing 4 knots. Having enough battery to do that for 6 hours, okay. If you're running 24 volts and you can do it on 30, 40 amps, let's call it 50 amps and deal with the waste, because 48 amps is the max draw of that motor. Okay, you're looking at 100 amp hours is 2 hours, 200 amp hours is 4 hours, so you want 600 amp hours. It's 3 batteries that are $600 each for each side, for each motor. Okay, so times 2, and that's just a lot of money. It's not an unrealistic, undoable amount of money over the course of several months, because you don't have to buy a $10,000 single battery. Boom. Like, you don't have to do that. So this is all approachable and growable, and it's kind of what I really like about the 24 volt system, is that it's upgradable easily. If I do 48 volt, I'm just stuck with getting a 48 volt motor and switching those. Minn Kota has some 36 volt motors that I might want to look at. I would trust the Minn Kota even more than the Newport to actually do what it says it does. A lot of pods that I can access are just going to be Chinese pods. Whatever, cheap stuff. House Swing, Alibaba, whatever. So that's you know, you pay very little and you just expect that they're going to pop, break, and you're just going to replace them periodically, because using them for hours and hours is at high amp draws is not really, they're not super high quality. They're not made to NASA specs or anything, right? They're you're going to get 5 minutes at full throttle, and then it's going to go into heat overload or something. You have to be careful with this. You kind of need to overbuild a little. And I'm trying to underbuild it first just to see what the capacities are. So that's a potential problem. Nonetheless, I think staying at 24 volt at first is easier. It's easier to charge. The standard charge controllers really like to operate at 12 or 24 volts. You can get 48 volt systems from Victron. Victron is what I use. You can get 48 volt chargers and control systems. That's totally easy, not a problem. But a lot of stuff is just the easiest, cheapest, best stuff is 12, 24 volt. It all works. Everything works on 12, also works on 24. Most of the stuff that works on 24 also works on 12, but not always. And then, you go to 48. 36 is kind of a weird redheaded stepchild. Like it's a really good in between. But it's not as common. Like it just doesn't seem as common. 48 volt backbone seems to be more common. So maybe go with that. I really think I'm going to try to do 24. And again, this is a very small, efficient little boat to use as a test bed for this, to get more experience with it and to try to do it. And once you're in the canal systems and you're down a little bit further south and you're into Florida and you're messing around with the Gulf ICW and the Keys, I think there's some stuff to be said for resale value, project value. So if we want to switch to something else later, there's something to be said for this. You can chop or remove or do whatever with the mast here, and you can go through a lot of Florida. There are people who just never leave Florida and live aboard and do their anchoring thing and enjoy the weather all year round, except when there's a hurricane. And you have some options there. If you want to go do the loop or cruise to Pittsburgh or whatever, you're going to need more power. You're going to need to have enough power to really push the boat. I talked to an engineer who's doing this on his own trawler. He's doing the loop on an electric trawler, and he doesn't speak sailboat a whole lot, but he just basically, given the length of the boat, coming from trawler land, he's assuming that 2.5 kilowatt pods is the minimum that's going to work. So maybe not. If I could get by with a little bit less, that might be cool. Like I say, Minn Kota has a 36 volt option that's a little bit more. I think they're 1.8 kilowatts, 1.75 kilowatts. I need to look it up again, and that's a possibility. That's actually it's a possibility. It costs a little bit more, and you're kind of locked into that 36 volt. 24 volt, I can always put them in series and get a 24 volt battery if I've got two, or a 48 volt battery if I've got two. So it's doable. Just depends on what you're doing. So I don't know, maybe. And that's so these are the things that come in to play. Do I work more on the outboard motor? Because there's a lot of stuff with the outboard motor that's not connected, that never was connected when we got the boat. Like there is an electric start, there is a magneto alternator. There's stuff that's not hooked up that I could do with this motor that would make this into an actual fully modernized yacht experience, like electric start. I could retrofit it for electric tilt. That would be neat. If I came up with a sliding track system for the up and down instead of the cantilever, instead of tilt, I could just have it go up You could use a little electric servo motor and a screw and have it go up, or you can just haul it up out of the water, and that would be really nice. So I can do that. The electric is going to pull me down in tech level for things outside of the motors just a little bit, rather than fixing up the outboard. But once I'm done with... See, I'm not done with gasoline if I do that, because there's going to be a generator. You're going to have a generator, or you're going to have to be willing to be stuck for a week at an anchorage because the sun didn't come out right, or you didn't get enough charge, or whatever. So the generator's a must. And the generator basically replaces the outboard as a gasoline engine to take care of. Except, of course, it's something, small, moderately sized generator, something you can put in your wagon and hike yourself down to Harbor Freight and replace it if you need to, from any city dock or whatever. Like you're in North Carolina and you go to the city docks, you can go replace your generator even more easily than an outboard. So, that's it. There's a lot of things, a lot of moving parts that go into this. The outboard is still probably the simplest option to think about. The other thing that comes into play, there's not a lot of sailing when you're doing the loop or the ICW. So even though we have the mast and the sails and everything up, you don't use them a whole lot. The mainsail, especially, you don't use hardly at all. We will often put a jib out if we're on any kind of bouncy water and the wind is at all favorable, because that steadies the boat, the motion of the boat, makes the boat go much more steady. Dampens the roll, makes everything nice and comfortable. Also, sometimes you get that 1/2 knot, 1 knot, or 2 knots of speed. We had a place up in Virginia where we were idling the outboard just because I didn't want to turn it off, and because the wind is a little shifty, and just on the jib we were doing 3.5 knots, so that's fine. It does happen. It does work. You can sail a sailboat. It's just that we're in a restrictive environment in those terms. So not using the main as much, the big thing that you can do to make it easier with electrics is to pull your solar arch and your bimini and everything and just frame it all the way forward to the front of the cabin hatch. Make it really tall so that you can stand under it and put up 1,200 watts of solar. Just put up a whole bunch of solar. 1,200 easy. Probably 1,600 is doable without making it look too weird. That's all easy to do. And some of it'll be aimable, tiltable and stuff, and you can make it so it's waterproof for rain, so that you don't have to deal with rain. And that's all doable, but you have to raise the boom a lot. Now we have a floating boom. It floats in the mast track, and we have mast gates, so there's no reason we can't just throw the boom up higher, and that's possible. It looks funny for people who are traditional sailors. You want the boom as low as possible to maximize how much sail you have. And I'm running one reef right now with the boom up a little bit, and I'm trying to figure out how high I can go with that and what that gives me, because I'm perfectly willing to sacrifice the mainsail for comfort, okay, because we are not taking this to the Bahamas right now. We're trying to cruise very little, and if we were on the trade winds, losing the reef point of the sail isn't going to make that big a difference. I can throw the 135 Jenny on, and we're going to sail just fine. So maybe it does increase the center of effort goes up. Okay, that's the center point of effort of the sails when you're sailing, goes up some when you raise it up like that, and that is a factor. But even though the Catalina 27 is a mainsail biased design. It really likes the main. It still runs just fine with jibs. If you run jib only, you can do it. And if you want to run the jib and the main, you can do that. You could still run main only. It's just going to be a little weirder, probably a little more rolly. To be honest, if you're doing the center of effort is higher and you have any real big wind, but for light airs and stuff, it's not that big a deal. And it gives you a whole lot more living space, which is a factor. Of course, we're in the middle of winter on the East Coast, and the whole East Coast is cold, so the cockpit is not much of a living area right now. And having a better, more permanent structure for that with solar panels would mean that we could put some roll down fabric and make it into a greenhouse room, Florida room, our friends call it, where you put the isinglass and you zip down the plastic. And then you have the outside gets nice and warm and toasty in the mornings with the sun, and you can live outside better. So that's a factor. And all of this stuff kind of goes together. I can make a swim platform out the back transom more easily if I'm running the electrics, or if I mount the outboard off to one side or the other. That's a factor. That does the same job. If I want to, either way, I'm probably going to raise the boom some more and increase my solar and my weatherproofing up here. I don't think I'm going to go full pilot house, but it's tempting. It's a very low boat, but we actually have a pretty decent standing height for the cockpit below the boom. The boom's actually reasonably high all by itself. Okay, at its design spec, it's still reasonably high. I'm only going up about 14 inches to do everything I want to do. It's not that big a deal. So that's a factor. I think, I'm undecided. I think that the electric motor project has potential for the future that makes a bigger difference. I do think the electric propulsion is coming down. Like, more and more people have it, more and more people are doing it, but there don't seem to be a lot of people doing low cost outboard style conversions, except for catamarans. There's a catamaran up the way in North Carolina that I know of that has two 4.5 kilowatt motor pods, and they're on big sliding arms, and they go down with electric power, and you can raise them up, and they run 48 volt systems, and they're just beefy and do everything, and they're great, but that's a $10,000 motor system used without batteries, so it's different, a little bit more oomph. If I was on a catamaran, a beachable catamaran, something 38 feet with a 14-foot beam, or 30 feet with a 14-foot beam, 30 feet, very lightweight and everything, then probably two of the Electech 5 horsepower outboard things would probably do it just fine. I think they're 36 volt, they might be 48 volt, but they run their own internal battery system, whatever. Something like that would probably work just fine. And that's going to give you 6-7 knots on a small catamaran. This is a smaller but very efficient boat, and it's very possible that we can do what I'm looking at doing for pretty cheap with low infrastructure cost. That's the other reason to try to stick with 24 volt, is I can just literally go to a store and get a Newport 24 volt motor, the 1.25 kilowatt ones, and take it and bolt it on. And if I can do that and it works, then replacing the two motors is easy at any given point in time, and so on, so forth, right? Replace batteries are easy, chargers are easy. It becomes something that you can actually do at a store, not have to order online, and sometimes that's important. The Minn Kota 36-volt system, I'll look into that. That's also a possibility. It's going to be a little bit more upfront cost because the battery, it's just the minimum acceptable battery system is going to be $800, $600 to $800, and that's just each side, and that's just your minimum. That you can't do anything else. So those are the factors to consider. I do think we're going to raise the boom and try to hard top and make that Florida man style boat. You know, serious sailors are going to look at it and be like, oh, you ruined your boat. And serious cruisers are going to be like, nice shade, nice wind, nice rain protection, very nice. And that's what I'm going for. Want it to look good. That's the hardest part, wanting it to look good. Along with that, you know, I thought about shortening the mast, having it pulled off next time we're near a yard that's cheap, and redoing it, cutting a significant amount out and redoing everything. I don't think that's actually... There's part of me that likes the idea. It has an effect on how the boat moves in the water. You've got that big, huge pendulum, and it's designed to have that big, huge pendulum. It doesn't do anything for us, right? Like it's just spending money for no purpose if we do it now. Getting the boat's air draft under 30 feet has some advantages on some parts of cruising in the eastern U.S. Not a whole lot. Getting it under 20 feet has a huge amount of impact for doing the Great Loop and everything. Like there is a 19-foot bridge in Chicago, and that's like the spot you have to be able to figure out doing the Great Loop. And then some of the canals you've got to hit 15 feet. That's how high above the water you can be to get through under bridges and stuff. That's just not, you know, at that point for this boat, you're talking about having a 10-foot mast, a 10-foot stub up there, and that's just unreasonable. There's no reason to bother. It's not going to work with the motion of the boat. It's not going to work with a lot of things. For that, you really want something that already comes with a swing keel, so that you can raise the bottom, the weight on the bottom, and improve your motion. And something bigger, honestly. Just different boat design. It's not a bad idea. It's just different boat design. And then what you have is you have a spar that you can use as a you know, lifting boom for your dinghy. That's basically what it amounts to. And antennas and stuff. It's not there for sails. You're not 10 feet is not enough. You know, it's not enough. 20 feet, which would put us under 30-foot air draft, is still kind of enough. It's a heavy dinghy rig, like it's going to look like a McGregor 26, but it is enough to do the job of moving the boat if you need to, or steadying the boat. I don't know if the pendulum mechanics work with a fixed keel boat like this. I probably have to reduce the weight of the ballast some to make it not... If all of your weight is down here, then your motion gets weird when you're in rolling seas. Whereas this, you kind of, if you got your mast up, you're kind of doing this. No mast, you'd be doing this, because the weight underwater would not want to move, so you're just going to swing around, and that will make you sick, and it's just not comfortable. So you have to kind of balance these things out. And you can do it by trial and error. Okay, there's absolutely nothing that says that you have to go get 5 college degrees and do it your own way, or do it the hard way and the math way. You can actually just, you know, cut 10 feet off your mast, put a 10-pound kettlebell on top, and see how it goes. You know, like see how it feels. You can do it that way. You don't want to take too much weight off the bottom, because if you're top heavy, then you're going to capsize. So that's the one thing to watch. And also blue water cruising is a completely different beast. Totally different. I'm not going out into 15-foot seas crossing the Atlantic. No. So that's not what we're doing with this. This is a flat water-ish loop, ICW, maybe the Northern Loop, maybe the Albemarle, maybe the Omaha, Nebraska to Pittsburgh trip. You can do that on the water. It's that kind of boat. The only thing to worry about there is that we do have a 4-foot draft on this, so there's still some limitations. But there's no reason to take the mast and mess with it that way at this point in time. It would be nice to be under 30-foot air draft for a couple of areas, but it's not, there's no reason to really do it. If this boat was amenable to being rigged as a schooner or a ketch with 2 shorter folding masts, like tabernacle masts, I would consider 16, 18-foot spars and doing it that way, and then pulling them down. And it wouldn't be as efficient, but there's not enough room. There's nowhere to mount the masts. It's not designed that way, so it's not happening. So probably not going to touch the mast. Just going to keep adjusting the shrouds, the standing rigging, make sure it's like up doing its thing, and running our jibs, light jibs. We're not trying to go stormy weather, full sail in a gale kind of thing. So just leave it there, but keep it as much out of our way as possible. And that's the raise the boom part argument. Once again, is raising the boom. We're not going to get rid of the boom. Tempting, but not going to get rid of the boom. Raising the boom gives us a lot of stuff, a lot of ability to just do the living space work here, and then possibly convert to electric propulsion. I want to hook up enough of it to try it out, and see if it's going to move the boat. Like where am I at? But I've talked to enough people who've done it that I know that it does work, and I know that you don't need the equivalent of 15 horsepower. You don't need to duplicate a 3-cylinder Yanmar engine to move a 27-foot boat. You can, the power requirements, if you've got the right prop design, are much lower than people would assume. People assume that you're going to drop and replace the 20 horsepower. You don't need a 20 horsepower diesel, but a lot of these Catalina 27s have a 20 horsepower diesel because people repowered them and that's just what they put in. You need an 8 horsepower diesel, okay? Some of them came with atomic 4s, and that's a whole nother thing, because it was a cheap engine, and that's just what it was. Even though some people rate them at 30 horsepower, some people rate them at 15, it's way more than you need. You don't need to replace that with that. You don't need to go with a 10 kilowatt, 15 kilowatt electric motor to do the replacement. And that's where most people in most sailboats that I've talked to who haven't really examined stuff get stuck, is they want to do a horsepower to kilowatt replacement, and it's way more than you need. So what do we need for this? What do I actually need? I've seen these boats pushed along like all day with 4 horsepower outboards. Not fast, but they go. And that's 3 kilowatts if you do it that way, if you do the math that way. Pounds of thrust, I don't know, maybe it's 2 kilowatts. That's why I'm going to try, probably, assuming it works out, the 2 24-volt Newports first, unless I go with the Minn Kotas in the 36-volt system. And that, well, talk to me. Tell me what you want to know. Tell me if you want to see the math. I'll put it up on the Substack, and we'll look at numbers and start running some stuff. And I'm looking forward to seeing how it works one step at a time. So stay sideways. Enjoy.